When you think of NVIDIA, you probably think of amazing-looking video games, right? But what if I told you that their whole quest for better graphics accidentally kicked off the AI revolution? Yeah, that's the story we're going to unpack today.
So that's the big question, isn't it? How did a company that was all about making games look pretty become one of the most important companies on the planet? To figure that out, we've got to rewind the clock.
All right, let's go back. Picture this. It's the 1990s. 3D gaming on PCs is just starting to take off. And game developers, they had these huge, epic dreams, but they were slamming into a massive wall.
See, back then, the computer's main brain, the CPU, was trying to do everything. It was like a one-man band trying to play a symphony. It was juggling the game logic, the sound, and trying to draw all the graphics at the same time. And it just couldn't keep up. It created this huge bottleneck, and the games, well, they just didn't look like the amazing worlds developers wanted to build.
And this is where the GPU comes into the picture. Okay, think of it like this. The CPU is like a master chef. Super smart, can handle really complex, intricate tasks, but he does them one by one. The GPU, on the other hand, it's a massive army of line cooks. They're not doing anything fancy, just thousands of simple, repetitive jobs like flipping burgers all at the exact same time. And it turns out, graphics is a 1,000 burgers problem. You see? The really important thing here is that solving the gaming problem meant they had to invent a whole new way to think about computing.
And that new way of thinking, it led to a huge breakthrough. The year was 1999, and it was about to change PC gaming forever.
So in '99, NVIDIA drops the GeForce 256, and they call it the world's first GPU. And this thing wasn't just a slightly faster graphics card. No, it was a specialist. It took all those repetitive, burger-flipping graphics tasks completely off the CPU's plate. This freed up that Master Chef CPU to focus on the really complex stuff. And the result? I mean, it was a quantum leap for how games looked and played.
Okay, but here's where the story takes a wild turn. This amazing engine, built for fun and games, well, it had a hidden superpower that no one really saw coming.
Because it turns out that the exact same kind of math that renders a 3D dragon in a game is also perfect for other incredibly complex stuff. We're talking about simulating weather patterns, figuring out how proteins fold, and, the big one, it was the key to unlocking the massive potential of artificial intelligence.
But there was a problem. The GPU was this incredibly powerful engine, but it was basically locked behind a sign that said gaming only. Then in 2006, NVIDIA gave the world the key. It was a software platform called CUDA. You can think of CUDA as like a universal translator or a Rosetta Stone. It let developers and scientists finally talk to the GPU and tell it to do, well, pretty much anything they could dream up.
And this was a total game changer. Seriously, all of a sudden, a small university research lab could get supercomputer-level results for a tiny fraction of the cost. They could just use a few off-the-shelf gaming cards. It completely democratized high-performance computing.
And you know, it was this new accessibility that directly led to one of the biggest aha moments in the history of AI, and that happened in 2012.
So in 2012, there's this big competition called ImageNet. It's like the Olympics for computer vision. A team of researchers decided to try something different. They trained their AI, their neural network, on a couple of NVIDIA gaming GPUs. And they didn't just win, they completely obliterated the previous records. It wasn't even close. That was the moment. That was when the entire world woke up and realized GPUs were the missing piece of the AI puzzle.
So, what's actually inside these chips that makes them so powerful? Let's pop the hood on a modern GPU and see what makes it tick.
The GPU has been constantly evolving. It's not the same beast it was back in '99. What started as this general-purpose parallel processor, it's now a super specialized chip. It's like our army of cooks didn't just stay line cooks. They specialized. Now you've got bakers, grill masters, sauciers, all working in perfect harmony.
So when you look at a modern GPU, you're really looking at this team of specialists. You've got the CUDA cores. Those are the workhorses, the raw horsepower doing most of the heavy lifting. Then you have the RT cores. Think of them as the artists, the lighting experts, calculating all the realistic light and shadows. And then you've got the tensor cores. These are the math geniuses, purpose-built just for the kind of math that AI and deep learning depend on.
Okay, so that's the tech. But what does it all mean for us in the real world? Well, it means that this engine, originally built just for gaming, is now the driving force behind some of the most important innovations of our time. I mean, think about it. From exploring the depths of space to understanding our own DNA, GPUs are at the very heart of modern science. They're the brains inside self-driving cars. They're helping to protect our financial systems, They are the engines of discovery in, well, in almost every field you can imagine.
And hey, if you need one more piece of proof of just how big this impact is, just look at ChatGPT. That revolutionary AI that changed everything, it was born on a massive supercomputer packed with NVIDIA GPUs. You can draw a direct line from the chip designed to make your games look better to the AI that can write a poem for you. It's incredible.
But here's the coolest part. This isn't a one-way street anymore. The relationship between gaming and AI has become this powerful, self-reinforcing cycle, a flywheel of innovation that's just making both fields accelerate like crazy.
It works like this. Step 1. Gamers. We're a demanding bunch, right? We always want better, more realistic graphics. That demand pushes NVIDIA to build faster, more powerful GPUs. Step 2. That new powerful hardware enables brand new breakthroughs in AI. But then, and this is the cool part, Step 3, that new AI gets used to create technologies that make gaming even more realistic and amazing. And then the whole cycle just repeats, spinning faster and faster.
And we're seeing this happen right now. Technologies like DLSS, that's pure AI, using machine learning to boost your frame rates and make games look incredible. And the next big thing? NVIDIA's working on something called ACE, which is designed to create game characters that are truly intelligent, that can think and react on their own. The student has literally become the master.
You know, the whole story of NVIDIA is just this amazing reminder that world-changing innovation can come from the most unexpected places. A technology that was literally built for play has become one of the most fundamental tools of our time. And now, as gaming and AI keep pushing each other forward, you just have to wonder, what incredible new worlds are they going to build together?